morning to all. My name is Muhammad Nabil Fikri bin Sharifuddin from Group 17, which is the SS. So today, me and my team will be presenting a little bit of our progress for the integrated project throughout this semester. I will start our presentation with an introduction of palm oil. Palm oil is an edible vegetable oil that originated from Africa. It grows well in wet and humid places such as Malaysia. Nowadays, Malaysia is one of the largest exporters for crude palm oil in the world, where over the last 25 years, from 2.57 million metric tons in 1996, increased to 17.368 million metric tons in the year of 2020. As a group of fresh chemical engineers, me and my team have proposed the process flow diagram for the overall process of the biodiesel production. Starting from the palm oil as the feedstock, it will flow and passes to the pre-treatment vessel to undergo transesterification reactions. The product from this reaction will then pass through several purification and separation unit before coming out as a commercialized biodiesel. Next, we move on to the first part of this integrated project, which is the reaction generator part. So me and my team had decided to choose continuous stirred tank reactor (CSTR) as our reactor for the plant. This is because it's the most common system in biodiesel production. And for this system, the first stage of CSTR will be used to add approximately 90% of alcohol and 10% catalyst to the oil. Before entering a second CSTR, the reactor system will go to a glycerol removal step. This CSTR will be operated by referring to this parameter as shown here. Firstly, we set the operating temperature at 300 degrees Celsius, and it helps to favor the transesterification reaction to occur. And we also use methanol as the alcohol in the transesterification reaction, as methanol is preferred because of its low cost as well as its physical and chemical properties. Methanol also gives the biodiesel produce a good viscosity and boiling point, as well as high number of cetane. And for the catalyst, we have chosen alkaline catalysts such as NaOH or H2SO4. This is because transesterification process are preferred in homogeneous alkaline catalysts, as this will also help to avoid side product formation and promote to bigger yields of our biodiesel. So next, I will pass the floor to Adham to continue for the next part.
Okay, thank you, Nabil. So I'll be talking about the process modeling and simulation part. Overall, we use a mixer, heater, and two CSTR as the main equipment in our modeling process. So we have two main ingot streams, which consist of triglyceride, which we use triolene, and methanol. The temperature is kept constant at 30 degrees Celsius and the pressure is kept constant at 1 atm. The next component will be used is mixer, which we use to mix the two reactants to produce a single stream, and the stream will enter the heater, where we will increase the temperature to 55 degrees Celsius as the temperature of our reaction. So here we will be using two CSTRs in series, in which the first CSTR has a volume of 1.205 meter cube, and the second CSTR will have a volume of 1.195 meter cube. So both CSTR will produce a conversion of approximately 90%. So I will pass to Imran to explain about the simulation and manual and calculation.
Okay, thank you, Adham. I, Imran, will be continuing the process modeling simulation part. So right here, after simulating the process, we have taken its value, and eventually we would compare it to the manual calculation that has been calculated in the reaction engineering part. So according to the table here, we have the manual calculation values on the left side here, and also the simulation value right beside to it. We will eventually use the formula actual value here minus expected value over the expected value, which the actual value is the simulation value, and the expected value, the manual calculation value. And then after that, we would get the percentage error of each component. For FA, we will get 6.38%. For FB, 0%. FC, 0.7092%. And FD, 0.0788%. Next, I will eventually check on the effect of temperature on the performance of the reactor. So, as we have here for temperature as the x-axis and the conversion as the y-axis, and as the temperature increases, the conversion also increases, which means that the relationship between the temperature and the performance of the reactor is directly proportional. Next, we will also check the effect of composition on the performance of the reactor. And it's seen here, as the composition increases, the conversion decreases. And lastly, we will see the effect of the feed flow rate on the performance of the reactor. And you see the FA note here, as the feed flow rate increases, the conversion would also decrease. So that's all from me. I would like to pass the floor to the next presenter.
All right, thank you, Imran. So for separation process 2, one of the objectives is to design a suitable separation process system to improve the quality of biodiesel. As you can see from the slide, these two diagrams are the block diagram and PFT of the separation system that our team made. The crude palm oil will first go into the reactor, then the mixer, methanol evaporator, washing, gravity settling, and lastly the adsorption column for the purification of biodiesel. So the first separation process system is the methanol evaporator. So most biodiesel production methods utilize methanol in excess over the stoichiometric requirements for the reaction, which is typically at the ratio of 2:1. In order to improve the efficiency of methanol usage, it is important to recover and reuse the recovered methanol. Therefore, the evaporation technique will be applied for methanol recovery, which is the flash evaporator as shown in the diagram. There are several steps required to remove methanol and water in flash evaporation. Firstly, the stream consists of mixture of biodiesel, glycerol, and methanol, which is heated as it passes through a heat exchanger. Next, the stream will later be sprayed at a high pressure into a tank where the methanol and water are instantly vaporized and brought to a condenser. The methanol and water will become liquid by condensation in the condenser, and both will be taken for further purification so that it can be recycled into the system again. The residual fuel and glycerol that goes to the bottom of the flash drum will be dry and drained off into storage. So the operating condition of the flash evaporator is as follows, which the temperature is 140 degrees Celsius and pressure of 361.38 kPa. So the next system is water washing. The contaminant of biodiesels include glycerol, soap, sodium hydroxide, and the residual methanol that does not come off during the evaporation process. Theoretically, there are two steps in water washing process. Firstly, acidification the mixture of the esters. Then it followed by 2 additional steps of adding water-crude biodiesel while stirring it slowly. Later, the water will be removed by sedimentation. Usually, the process will be repeated for 2 times to ensure that all the contaminant of biodiesel is perfectly removed. In water washing process, water is being used because it has a strong anion, which is hydrogen atom, and all the contaminants are water soluble. By stirring the water slowly, it encourages all the contaminants to get attached to the hydrogen atom of water and restricted the formation of emulsion. Thus, more contaminants of the biodiesel can be removed. Some types of water washing techniques that have been used include bubble washing, stirring methods, spray washing, and hot water washing methods. In our separation system design, we have decided to use the hot water washing method. The reason for this is because this method has been showing the increasing yield and purity of biodiesel and meet the biodiesel standard. It has also been reported that the unreacted catalyst, sodium hydroxide and glycerol can be removed using hot water washing at 60 degrees Celsius and volume ratio of 1:1:3:1 of water to biodiesel ratio after 20 minutes. So once the process is done, the mixture will be brought to gravity setting for further purification process. Thus, the specifications for the water washing is temperature of 60 degrees Celsius and the pressure is 101.325 kPa and ratio of 3:1. So next, I will pass the floor to Amir.
Thank you, Ain. So now I will be talking about the gravity settling. So the gravitational settling can be used to separate not only glycerol but also sodium hydroxide and the unreacted reactant from the biodiesel due to the density difference and also the low solubility of the material in the biodiesel. The gravitational settling pretreatment could be used as the first and simplest step immediately after the trans-esterification reaction. And then by accelerating the decantation process before the biodiesel downstream, the purification process so that it could significantly reduce overall production cost. In our separation system, we also use the gravity settling after the water wasting process. In the adsorption column, the adsorbent that we use, we also use to remove the impurities or contaminant in the biodiesel. So some of the adsorbent that we use is magnesol, activated carbon, and activated fiber. In our adsorption column, we will be using the activated carbon, where the activated carbon have a huge porous volume and also has a huge surface area, which allow more contaminants to be absorbed in the adsorbent. So the operating condition will be 65 degrees Celsius and YATM, and also the time spent in the adsorption column will be about 20 to 30 minutes. So lastly, from our biodiesel production, with the assumption of 95% efficiency in each separation unit that has been mentioned, so the final stream exiting the adsorption column, which is S12, will have the overall biodiesel mass flow rate of 376.522 kilogram per hour. This is equivalent to 3,298.33 ton per year. And the purity of the biodiesel can be calculated as mass of biodiesel over overall mass. So the purity of biodiesel is calculated as 99.93%. And so the objective of our study is to produce 3,000 ton per year and with the highest possible purity of biodiesel. With that, we have achieved our objective. And that's all from us. Thank you.